This discussion relates to Lecture 15x, page 2, CHMI 351, Descriptive Inorganic Chemistry, and we'll talk about different chemical substances and how they behave in water, i.e. are they acidic, basic, or are they neutral? An example would be sodium acetate, which some of you may be familiar with from your previous courses. Sodium acetate is, and I'll model it this way, is a solid, and when placed in water, becomes aquated, which is a dissolution process, part of the solubility process or solution process. So let's say dissolution. Since the sodium acetate is a strong electrolyte, let's look at that modeling where it dissociates completely is what we assume. So I got sodium acetate, aquated species, completely dissociates 100% is what we assume for all sodium water soluble salts, and we get sodium ion and the acetate ion. So the question is, what are these? How do these two behave? Well, in a previous discussion, a previous video, we said this was a spectator ion, and it can act like a Lewis acid or an indirect Arrhenius acid. But its Ka we modeled as approximately equal to 10 to the minus 18. So as an acid, it's weaker than water. So that's why we call it a spectator. Again, that's on a totally different video. So now what we're going to do is focus on the other species, which is the acetate ion. So we actually have sodium acetate as the salt of a weak acid, acetic acid. And people model it different ways, but I like doing it this way because it shows the acidic hydrogen. So now we're talking about the salt, which is related. So it's the conjugate. So we're looking at the conjugate base, if we're looking at the Bronsted-Lowry definition. So let's look at that behavior. If it acts like a base, then we should get hydroxide ion in solution. So let's hydrolyze water. And what we get is hydroxide ion, aqueous, plus the conjugate of the acetate ion is acetic acid. But then who in fact determines the acidity or basicity in water? Well, it's the hydroxide. So we don't look at the weak, we look at the strongest, and the strongest species present at this particular time is the actual hydroxide ion. So the solution is basic. We suggest the pH is greater than 7, and from previous experiences you may think the pH is between 8 to 9 based on some analytical calculations, which we're not going to do here today. So the question is, well, how strong of a base is this? If we suggest that, then we should be able to find out what the Kb is for the acetate ion. Well, the Kb is related to the Ka for acetic acid. So there's the conjugate, is acetate, acetic acid, that equals my Kw. And we know Kw, for all practical purposes, 10 to the minus 14. We look up the Ka for acetic acid, we find it's 10 to the minus 5. Therefore, we're assuming that the KB is 10 to minus 9 and 10 to minus 9. Anything above a Ka of 10 to minus 5, 7, 10 to minus 7 is considered very weak. We're on a very weak side. So we don't expect a lot of that. So we would expect the equilibrium arrows to favor the reactant side or the left-hand side.